Good morning, friends. It is Wednesday, April the 22nd, and coming to you today from a different location because it has just been raining like crazy, and so here in Alva, and so I was able just to do everything from home today, so I didn't have to pretty much wade into campus. So I just want to celebrate with you because today is our last day of notes. So it is the last set. In your chapter 6 packet, there is 2 other sections, but we will not be going into that. We are just going to end today with systems of equations. And so today is our last day of notes. So yay, celebrate. And then from here on out, we will be preparing. We have one more quiz on Friday, a 6.1 quiz over what we're going to do today. And then on, I'm going to give you a review, and then we'll go over the review on Monday, and then you'll have a test next Wednesday. So that's kind of the plan. And then we will review for the final and get things started there. And then you will be ready to finish up. So again, we changed our final to May the 4th, Monday, May the 4th, as I gave that survey. It was pretty well. I only had like 2 out of 52 students that wanted to keep it on the same day, so we did go with majority rules. And if you were one of those students that wanted to keep it on the same day, then we can make arrangements. So you just need to let me know that. But all is well. So, okay, well, let's dig into 6.1. So what we want to look at today, we want to end on a high note. So if you can solve for x, you can do what we're going to do today. So looking at chapter 6, it's all about systems of linear equations. And what a system is, sorry for my fingers in it, when I use my document camera to take a picture, that's what happens. So, okay, so a system of equation is 2 or more equations considered together. So what we're going to look at today is 2 equations, 2 unknowns. So we'll have an xy. You can do 3 equations, 3 unknowns, and that gets you into 3-dimensional figures. So, okay, so a solution to a system of equation is an ordered pair. So when we think about that ordered pair, it's an xy coordinate that we can substitute into both equations, and it makes it a true statement. If we think about this graphically, it's where your 2 linear functions intersect. So where do your 2 lines intersect? That's the point we want. What point do they have in common? So that's what we're going to find today. Okay, so if we think about our 3 possibilities, okay, our 3 possibilities is the first one is what's known as an independent system, okay, and that's not as important as just what it means. So an independent system has exactly 1 solution. So what that means is where it intersects, it has 1 point, okay, 1 point, and this is what the majority of them look like, okay. The second type of system is a dependent system, and that means it has infinite solutions. So how you know you have this case is if you lose your variable and what is left is a true statement. Okay, so if you're left with 5 equal to 5, 7 equal to 7, 0 equal to 0, that means that's a true statement. Okay, and if I think about that graphically, basically it's the same line. So it's right on top of each other. So that means every xy coordinate is what they have in common. So that's why it's infinite solutions. The last one is an inconsistent system. Inconsistent system. And this has no solutions. Okay. So if we think about it graphically, if it has no solutions, that means the 2 lines never intersect. Well, what lines do we know never intersect? Those are parallel lines. So that means that these 2 equations have the same slope and they'll never intersect. So how you know you have no solution is if you lose your variables and what is left is not a true statement. So if you have 5 equal to 4, okay, 0 equal to 7, what is left is not true. Okay, and we'll see that in some examples. Okay, so the first one, apparently I did not get all of the directions. Okay, so in this case, there's 2 ways that you can solve. You can solve by substitution and by elimination. So the first way I want to show you is by substitution. Okay, so the first example, and this is what they look like. It has a large bracket on the left-hand side and then your 2 equations. So for this one, you have For substitution, your goal is to pick one equation, solve for one variable, and plug into the other equation. It does not matter which variable you solve for. Okay. Now, looking at this one, one of them is already solved for y. So that means you want to take your negative 3x, substitute into the top equation, and that's what I have here. Okay. And then it's all in terms of x. So then you want to solve for x. So I end up getting x is equal to 4. Now, once I get x is equal to 4, I want to substitute back in to y equals negative 3x to solve for y. And so I end up getting negative 12. So again, your solutions should be an ordered pair. So as you do your quiz, make sure you write it as an ordered pair. So 4, negative 12 is my solution there. Okay, let's look at the next one. So the next one, again, we want to pick one equation, solve for a variable, and plug into the other equation. So for this one, I chose the top, and I chose to solve for y. Again, you could have chose the bottom and solved for x. That part does not matter. Okay, so I solved for y, and I got y is equal to negative 3 halves x minus 2. And just so you know, on this one, any variable you chose for either equation, you were going to end up with a fraction. So know that sometimes you do have to work with the fractions. So then I want to take what y equals, and I want to substitute it into the other equation, and that's important. Never substitute back into itself the same equation, because that will end up losing your variables. Okay, so substitute into the other equation. So that's what we've done right here. Okay, you want to distribute your 6. You end up with 9x minus 9x minus 12 is equal to negative 18. So your 9x's go away, which means you lose your variable. So this is either no solutions or infinite solutions. And negative 12 does not equal negative 18. So that means that you have no solutions. Okay, so if we think about this line, if we looked and tried to find the slope of these two lines, they would end up having the same slope. Okay, so they're parallel lines. Okay, so that is the way, that is for substitution. Okay, take one, solve it for a variable, substitute it into the other. Now, the other way is by elimination, and this is usually the preferred method. Well, it really depends on what it looks like, but this one's really, I thought was really hard to explain in words. So in my words, I did choose a variable, okay, choose a variable to eliminate, multiply to get the same number, and then add your equations. So the goal here is you want to eliminate x's or y's. So you want to choose, do I want to eliminate x's, do I want to eliminate y's? And in this case, I chose to eliminate y's because I had a plus minus combination. Because if you look down here below, you can kind of see, okay, if I have a positive negative of the same, it goes away. So if you choose the one with a plus minus combination, that gives you one step ahead. Okay. Now, I chose to take this to 10, so that means the top needs to multiply by 2, the bottom needs to multiply by 5. Multiply all the way across, okay, all the way across. And then add those equations together, and when you add those equations together, you end up getting your y to eliminate. You get 10y minus 10y, so it becomes 0y. You lose your y. You're able to solve for negative x. Now, or for x. Now, once you have x, you want to plug back into one of your original equations. It does not matter which one you choose, so just pick one. Sorry, a car just went by. I have the door open. It does not matter which one you choose, and so just make sure you plug back into the original. So we can solve for y, and then I get negative 2, 5, and again, it's an ordered pair. Okay. So again, the next one. So for this one does not have, oops, did I miss one? Yep, I missed one. Okay, let's go back to this one. Okay, so first of all, you want to choose, do I want to eliminate x, do I want to eliminate y? So in this one, I chose to eliminate y because of the plus minus combination. Okay, so I wanted to take it to 20. So you just want to take it to a number that both will go into. So what number will 4 and 5 go into? 20. So multiply the top by 5, the bottom by 4. You end up getting your y's to go away, and you're left with x is equal to 2. Okay, and then take your 2, substitute it back in, take your 2, substitute it back into one of the equations. So for this one, I chose the bottom one. Okay, and again, it does not matter. You'll get the same thing for both if you have a correct x. Okay, and you end up with the coordinate 2, -1. 2, -1. Okay, this last one. Now, if you notice, if I'm picking x or y's, there's no plus minus combination. So if there's not one, then you have to create one. Okay, and so I chose this one to eliminate the x's. And so I'm going to take them to 10, but I need one of them to be negative. You can make the top or bottom negative. Okay, I chose to make the top negative. That part does not matter. Okay, just choose one. So when I put -5 through, and then I put 2 through. Now, when I add these together, I end up losing my x's, I lose my y's, and I lose my constants. So that means I have 0 equal to 0 left. Okay, 0 equal to 0. And so what that means is 0 equal to 0 is a true statement. So I lose my variables, I have a true statement. So that means infinite solutions. Infinite solutions. So, okay, well, that finishes up systems of equations. So our here's some homework if you want to try it. A couple of things. Again, Friday you're going to have a 6.1 quiz that's going to post into WebAssign. It's going to open up, and it's due by Saturday at midnight. So you have 2 days to do that. And then also on Wednesday, or also on Friday, I will post the chapter review. So you can work on the chapter review, and then we will have a Zoom meeting next Monday, and if you have any questions you can ask then for this chapter test, and then our chapter test will be on Wednesday. Okay, Wednesday, and then we will go from there and discuss the final. So we are coming down to the end. We are very close, so please make sure you stick with me. If you have any questions concerning grades, if you have any questions concerning W's, if you have a concerning your P or NP, okay, whether you should take a P or N, or whether you have the option to take the P or have the option to take the NP. So if you have questions about that policy, please ask, because there's quite a bit of confusion there. So I hope you have a great day. Again, if you're in Alva, it's raining, or in Oklahoma, it's supposed to rain all day today. So they had some huge hail last night south of us. So anyway, I hope you have a wonderful day, and we will see you on Friday.